Hey guys, today we're going to talk about, in this video, we're going to talk about prime factorization, which is breaking a number down to all the prime factors that multiply together to give us that number. And the method that we're going to use is called the cake method. You'll see in a minute why we call it cake method. We do an inverted cake method sometimes to find the least common multiple and greatest common factor of a number. And so we'll work a little bit on that later. But today we're just going to do a general cake method. Should give you some ideas. I'm going to ask you on a worksheet to do that method and the tree method. The tree method you should have already seen that. It's available on Canvas. I'll see if I can make it available on YouTube once I learn how to do that. This is all new to me, so just let me know what I can do to make it better if it seems a little odd to you. So as we work on this, first thing we're going to start out with, we want to break numbers up. It's different than tree method because in tree method, it didn't matter which numbers you used. In cake method, the numbers that you have to break out of it and you have to find first are you always want to find prime numbers that will go outside of it. So when I'm looking at 36, because I look at 36, I'm going to draw this division sign over the top of it. Now, in a minute, you're going to see that as we keep adding up these division signs, it looks like a cake. But I have to ask myself, what's the first prime number that I can think of that goes into 36? So prime numbers, 1 is not a prime number. It's a unique number because a prime number is its only factors are 1 and itself. Well, 1 is itself. And so it would be considered a unique number. But not prime numbers would be 2, 3, 5, 7, 11, 13, 13, 17. So when I look at this at 36, the first number I can think of is 2. 2 times 18. So all I do is go down to the 2 column on my multiplication table, and I can see that 2 times, I go down until I hit 36. I look over, that's going to be 2 times 18. Okay, so 2 is prime, so I have to ask myself, is 18 prime? And I can say that no, 18 is not prime. Okay, so now if I look at 18, the first prime number I can think of that goes into 18 is, well, 2 again. 2 goes into it. Then I go down the 2 column until I see, on the multiplication table, until I see 18, and that's going to be 2 times 9. So then I think about it, and I'm looking, and I say, well, 9, 2 doesn't go into 19, but 3 goes into 19. And so I go down the 3 column until I see the 9, and that's going to be 3 times 3. And so when I look at the 3, then I see that, well, 3 is prime. So I put the 3 out here, and 3 divided by 3 is 1. When I get to the 1, I'm done. So by magic, we have that up there on the message that when you get to the 1, you're done. And a lot of students will refer to that, and they get to where they see that, okay, when I get to the 1, I'm done. You know you're finished. Now what I'm going to do is I have to pull these numbers down. And again, as we talked, we're going to put it in expanded form, and we're going to put it into exponential form. So when I look, I'm going to take it, I still need to put things in numeric order. So I'm looking at this and say, well, 2, 2, 3, 3. That's pretty much numeric order. So the expanded form of this is going to be 2 times 2 times 3 times 3. The exponential form means I'm going to put things in terms of the base and how many factors of that base. So here the base is 2. It's 2 to the second power times 3 to the second power. These are both useful forms to represent the number. And as I'm trying to reduce fractions, I'm trying to find the least common multiple or the greatest common factor of a fraction. It's going to help you a lot with fractions, with factoring, polynomials in the next couple of years. As I've said, if I were you, I would hold on to these. I would put these in a place where you're going to be able to remember them. Okay? Okay, let's try another number. So we're going to look over at 48 now. And if we look at 48, again, it's not prime because I can think of a number of different things. So the first number, if I look, I can see that 8 is in the ones digit. If you have a 0, 2, 4, 6, 8 in the ones digit, then 2 is a factor of that number. The other thing I can do is I can add 4 plus 8, which gives me 12. If I add the digits, of that number, and 12 is divisible by 3, if I add the digits and the sum of the digits is divisible by 3, then that number is divisible by 3. So I know that 3 is a factor of 48. But I'm going to go with 2 first just to keep my life simple. And again, if I go down the 2 column on the multiplication table, then what I could see is that 2 times 24 is 48. And again, now I'm going to look at 24. And if I look at 24, again, 4 is an even number. So I know 2 goes into 24. 2 times 12 is 24. So now when I look at 12, 12 is not a prime number. And so now I'm considering 12 when 2 goes into 12. 2 times 12 divided by 2 is 6. And now I'm going to look at 6 and ask myself, well, 6 isn't a prime number. So when I look at 6, I know that 2 is also a factor of 6. 6 divided by 2 is 3. And finally, when I look at 3, I realize that 3 is a prime number. So 3 divided by 3 is 1. And like we said, if you get to the 1, you're done. So now I need to write this in expanded form. Fortunately for me, I've kept things in order. So I have 2 times 2 times 2 times 2 times 3. So my expanded form is going to be 2 times 2 times 2 times 2 times the 3. Which means I have 1, 2, 3, 4 factors of 2. So that's going to be 2 to the 4th times 3. And you can put to the 1st if you want there. It's not important because we have 1 factor of 3 there. Okay, so now if we go to 16, 16 is, again, if you think about it, we've seen 16 already once. But when we look at 16, we're just doing the same thing. We look, what's a prime number that will go into 16? And so when I look on my multiplication table, I'm looking down the 2 column and I see, oh, well, 2 goes into 16. 16 divided by 2 is 8. And then 8 is not a prime number. So 2 goes into that. So 8 divided by 2 is 4. 4 is not a prime number. So 2 goes into that. 4 divided by 2 is 2. And 2 is a prime number. So 2 divided by 2 is 1. When I get to the 1, I'm done. It's kind of like, if you look at it, this is a birthday cake, right? Kind of looks like a little birthday cake. And then you have the candle. And that's the last part of doing the cake, is you put the candle on there. So when you get to the 1, you're done. So again, I'm going to look at this and try to write it out in expanded form. So 16 is 2. Well, look at that. I just have 1, 2, 3, 4 factors of 2. So it's going to be 2 times 2 times 2 times 2. Now, if you want to, if it makes you feel warm and fuzzy, put the 1 there. But everybody assumes the 1. He's kind of the brother nobody talks about, right? Now, you know what I'm talking about. If you don't, maybe you're that brother. But so 2 times 2 times 2 times 2, which means this is going to be 2 to the 4th because there's 4 factors of 2. And so this is our expanded form. And this is our exponential form. Now, when we look at 11, well, 11's prime. If I look, I can't find 11 anywhere on that multiplication table except for the rows on the top and the rows on the left. So 11 must be prime. I mean, 4 is on the top, but 4 is also in that multiplication table. 6 is on the top and on the left, but it's also at 2 times 3. So if it's the only time you can find that number in there is that it's on the top and on the left, then it's probably a prime number. Now, there's some numbers that you're not going to know are prime, but we'll work on that. So 11 is done. It's completely done. Okay, so that's how we factor a number completely using the cake method. Now, once you've practiced this method and the tree method, I really don't care which method you use. Matter of fact, you'll see that on your homework for this, you're going to do some of them in tree, one page in tree method, and part of the second page in cake method, and the last 6 to 8, you get to do the way you prefer to do it. What you do have to do, though, is you have to have this expanded form and this exponential form of each number. So be careful. Remember, if we look, when we multiply any of these numbers, these prime factors together, they give us our original number. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 3 is 48. 2 times 2 is 4. Times 3 is 12. Times 3 is 36. 2 times 2 is 8, or 4. Times 2 is 8. Times 2 is 16. When we get done, we can check to see, just by doing this simple math, to make sure our prime factorization equals that number. On your hundreds chart, you'll need to be able to represent each number as expanded form or exponential form on the bottom of that number. Okay, when you do the hundreds chart, it should give you a lot of patterns. You should start seeing some things that are going to help you, hopefully with your multiplication, really help you with your fractions. Those of you that struggle with fractions, like 4 out of 3 people, you're gonna appreciate this if you use it, and if you learn how to use this tool, it'll be valuable. Okay, have a good day. Let me know if there's anything I can do to be improving these videos, and give me feedback on how these helped you. Remember, you can watch these, pause them, do whatever you want with them, take notes. These would be valuable ones to have notes on. Okay, have a good night.